In this section, we're going to be looking at polar graphs. So we're going to have equations that are going to determine different polar points. And then the graph is just going to be a set of all the r's and thetas, so all the polar points that satisfy those equations. So remember in the previous section, we looked at a different way of doing points. Instead of a point being the x and the y, the horizontal and the vertical distance, now we've got an r comma theta. Where we look at the angle that we rotate, and then we look at the distance from the origin, and that tells us what point in space we have. Now, even though the points are r comma theta, we really want to look at the theta first and then the r. The theta is going to be our input variable, our independent variable, and the r is going to be our dependent, our output variable. The only reason the points are written this way is alphabetical. Theta is the Greek letter T. When we plot points, we want to look at the theta first. When we make our table, we want to look at the theta first. Okay, so if we look at this, just like anything else, if we're trying to graph something that we're not sure how to do, we always start by just making a table, and we'll use our good old quadrantal angles here will usually be enough. And we're just gonna plug in the numbers and fill out the table and then plot the points. So if we take the angle 0, so we want to find the cosine of 0. Cosine of 0 would be 1. So 2 times 1 is 2. So we're going to have -3 plus 2. So this will be -1. And then we'll plug in pi over 2. Cosine of pi over 2 is 0. And so this whole second part here is just going to be 0. So we're just going to have -3. And then when we plug in pi, cosine of pi is -1. 2 times -1 is -2. So we've got -3 plus -2, -5. And then plug in 3 pi over 2. Cosine of 3 pi over 2 is 0. And so -3 plus 0, we get -3. All right, so then this gives us a bunch of polar points to plot. All right, so we're going to go the angle 0. Well, the angle 0 is right over to the right here. Okay, but then we've got an r of -1. Remember, negative r's tell us to go in the opposite direction. So instead of being where the angle 0 is, we're going to flip across the origin in the opposite direction. Instead of going right, now we're going to go left, a distance of 1. And so we're going to be right here. Okay? Then we're going to go an angle pi over 2. The angle pi over 2 is straight up. So right now we're looking straight up, but then that -r tells us to flip around and go the opposite. Instead of going straight up, now we're going to go straight down, a distance of 3. And then we go an angle of pi. That's over to the left here. But then because r is negative, instead of going 5 to the left, we go opposite across the origin. We go a distance of 5 to the right. And then an angle of 3 pi over 2 is straight down. And then the r of negative flips me back up to the top. Distance of 3 is right here. Watch out for these ones where it's pi and a negative and 3 pi over 2 and a negative. For some reason, those can mess with some people a little bit. Like 3 pi over 2, you're already down in these negatives here. You feel like this negative should kind of be satisfied by the fact that you're going down. It's already negative, but this negative doesn't mean like a negative x or y, right? It just means the opposite. Instead of doing 3 pi over 2, we do the opposite direction. So 3 pi over 2 with a -3 flips us up to a y coordinate of +3 right there. Those just kind of mess with some people's brains sometimes. So just be careful with those. Just remember the -r, just go in the opposite place of the angle. All right, so we've got these 4 points here. And then remember, polar is kind of a circular system. And so these graphs, you just want to kind of draw something semicircular around this. So what this is going to look like, it's just going to kind of be something like this. Something kind of circular around that. It's called a limaçon. There's a name for these. French limaçon. You don't need to know that. These kind of shapes do actually show up. They are used at different times. Actually, different types of microphones. The sound field, the pickup field for how different microphones pick up sound, is represented by different types of limaçons. So there's one application for how these types of things get used. But you don't need to know any of that. Right now, all we're doing is we're just making a table, plugging in numbers, plotting points, just doing it in polar instead of x and y, doing r and theta. So why don't you go ahead and try the second one here. Fill out that table and then sketch those points. All right, your graph should look something like this. This type of limaçon is actually called a cardioid because it's kind of a heart shape, right? If it's an upside down heart, that's kind of a heart shape right there. So when you plotted this here, again, just plug in those angles into there. Notice when you have an R of 0, that keeps you at the origin right there. That's going to be important. That's going to come up later. It doesn't matter what angle we rotate. If R is 0, that means the distance from the origin is 0. We just stay right there. All right. Just watch out for, again, this 3 pi over 2, negative 4. You go 3 pi over 2, which is down, and then the r is negative, tells you go on the opposite spot. Okay? You don't stay here because you see that negative 4. R is negative 4, tells you to go in the opposite spot. Okay? So that's limaçon, so just make a table. Now let's try some other simpler equations here. So all of these had a number and then plus or minus a number, cosine, or sine. That's what makes it a limaçon. There's a number, plus or minus a number, and then cosine or sine. Here, we'll first just do r equals a number, and then r equals a number times sine or cosine with no plus or minus in there. All right, so let's think about this first one here. R equals 3. So we want all the points where r is 3. It doesn't matter what angle we have. We just have r is 3. So we want a distance of 3 from the origin for any angle. Right? So we could have a distance of 3 from the origin out here, a distance of 3 from the origin this direction, a distance of 3 from the origin there, a distance of 3 from the origin right there, right here, right here. Hopefully you can picture what this shape would be. This is actually the definition of a circle. This is a circle centered at the origin with a radius of 3. The definition of a circle is the set of all points a certain fixed distance from some center, right? So we've got a fixed distance of 3 from the origin being the center. It's just a circle. Easy. All right. So now what about if we have a number in front of sine or cosine like this, okay? Now, you could make a table on these. We're actually going to recommend there's a particular shape and way that we can just know what these look like that we'll recommend that you know. But if you forgot what it was, you could always start with a table. All right, so let's say we wanted to try to start with a table here. If we had 0, pi over 2, pi, and 3 pi over 2. So sine of 0 would be 0. Sine of pi would be 0. Sine of pi over 2 is 1. 2 times 1 is 2. Sine of 3 pi over 2 is negative 1. 2 times negative 1 is negative 2. All right, now both of these with an r of 0 are going to be at the origin, right? Oops, let me switch to blue here. So it doesn't matter what this angle is, doesn't matter how you rotate. If you don't go anywhere, if you have no distance from the origin, you're stuck at the origin. So those 2 points are both at the origin there. All right, now let's try the other one. So we rotate pi over 2 and go a distance of 2. And then we rotate 3 pi over 2, but then r is negative. That flips us back up at the top, a distance of 2. We get the same point again. Okay? These points are kind of duplicated there. They're overlapping. So if you make a table, you're just going to see 2 points. So eventually what you're going to need to know is just that these are circles. Okay? All 4 of these are circles. All of these graphs are circles. All right. And it might come up sometime where we might ask you to choose between a graph where this would be an ellipse or a circle. We want you to know this is actually a circle. So these are the endpoints of the diameter of the circle here. So you can see the diameter is 2, so the radius would be 1. So I can see my center is right here, the radius of 1 there. So I can go out a radius of 1 here. I can go out a radius of 1 right there, and then I can draw my circle. Okay, this is a circle. It's not an ellipse. All right. So you could, again, if you wanted to, you could make a table for all of these, and you would at least get some endpoints of a diameter, and then make your circle from there. But notice on this one, we had sine in the equation, and the circle is on the y-axis, right? Kind of makes sense. Sine kind of goes with y-axis. We kind of saw that, and with these equations as well, right? We had sine in the equation, and the heart is kind of oriented along the y-axis here. Again, it was upside down heart. That's a cardioid shape, kind of like a heart, but it was is on the y-axis, was kind of the center of the graph here. This one was a cosine equation, and kind of the dividing line, maybe even axis of symmetry, if you want to look at it that way, is on the x-axis here. Okay, so what we're going to see is that when sine is in the equation, the graph is going to be oriented along the y-axis. When we've got cosine in the equation, the graph is going to be along the x-axis. So this one is still going to be a circle with a diameter of 2, but instead of going straight up along the y-axis, cosine goes with x. So it's going to be along the x-axis. Right? So the number out front, that's the largest that this can be. That's the highest value for r, right? If we thought about it like y equals 2 cosine x, the amplitude would be 2, the highest value would be 2, right? So the farthest out that we can go is 2, and because it's cosine, we're going to go along the x-axis. Cosine goes with x, sine goes with y. Cosine goes with x, sine goes with y. All right, so we've got these endpoints of our diameter here. Again, the radius is 1, so I can go radius of 1 there, and a radius of 1 there, and it is a circle. All right, and then, well, okay, this one we've got sine. Sine means it's going to be on the y-axis, but now because I have this -2, instead of being on the positive side of the y-axis, now it's going to be on the negative side of the y-axis. It's going to go from here to here. And again, you could always do a table to figure out the endpoints of the diameter, but you can see it pretty easily looking at the equation. And again, we'll go a radius of 1 from the center for the rest of the endpoints of the circle there, and draw the circle. Now we've got cosine, so it's going to be on the x-axis. Negative means go to the negative side of the x-axis. So there's my endpoints. Here's my center. Got a distance of 1, a radius of 1 from the center. And so there's my circle. Okay, so it actually is, it does come up in AP Calculus where it is really helpful to know that when you've just got r equals a number times sine, or r equals a number times cosine, that's just a circle. That is a good thing to just know. You can make a table to help yourself out a little bit, but you want to know that. You want to know that these are circles. All right, so we've seen circles, we've seen limacons. There's one other special type of polar graphs that comes up in AP Calculus, a petal graph. There's flowers. So we drew a heart earlier. Now we've got a flower graph, all kinds of fun graphs in polar. So here, when we put this number inside the sine or cosine function, that's going to create these petals, this petal graph here. All right, now what we found in AP Calculus is that you actually don't really need to know how to graph these without a calculator. What you need to be able to do is you need to be able to find different angles that correspond to different points on the graph, right? Now, saying that actually just reminded me that I forgot to show you earlier, you actually can graph these in your calculator. Let me go back. Let's go back to this one, and let's show you that. So if you want to graph this in your calculator, so normally when you graph things, you just had a y equals button there. So we need to change that to r equals. So we go into our mode. So we saw recently that pair was for parametric. There's also pole. So let's go over to pole. Pole is for polar. So if you use the arrows to go over there, hit enter to polar mode, then your y equals button, it's actually r equals. And so we can type in -2 plus 2 and then the sign. And then again, this button right here, when we're in function mode, it gave us x. When we're in parametric mode, it gave us t. Now that we're in polar mode, you can hit this same button that's next to alpha, and it will give you theta. All right, and then I'd recommend just do a zoom 6. Right, you can see it looks something like that. Now, your calculator's not, the dimensions aren't quite exactly right. Like it's longer than it is high. Your calculator screen is a rectangle, but this is usually not shaped like that. If you want to kind of fix that, what you can do is you can do a zoom square. If you do zoom 5, zoom square, it'll kind of fix that that distortion a little bit for you. Like if you graph some of these circles here and just zoom standard, they might not quite look like a circle. You can do zoom square to make it look better like a circle. Also, it's kind of zoomed out a little bit. I found for polar graphs, a lot of times zoom decimal works pretty well. If you do zoom 4, zoom decimal, that tends to be, it cuts off a little bit here, but it tends to show you maybe just a little bit better some of the graphs. So you can do these in your calculator. Just go in your mode, go to mode and change that to polar. And you can do it in your calculator, but most of this we'll do without our calculator here. All right, so as I was saying though, for AP Calculus, you tend to not need to know how to actually graph these by hand. What you need to be able to do is find different values of theta that correspond to points on this. And the important points that come up in AP Calculus are the tip of the petal and the point on the origin. Those are the points that you need to be able to find what value of theta gives you those points. Right? So let's start with the tip of the petal. Okay, so the tip of the petal, well, the tip of the petal is the furthest out that you've gone, right? If you're at a tip of the petal, that's your maximum R. That's your greatest distance from the origin. So tip of the petal is your maximum R. All right. Well, let's try to see what that is. Take a look at this petal down here. You can see this petal is at the -4 here, so that means we know that this maximum distance out to that point right there is 4. So that means all these other petals, if we go out to this point right here, same thing. We're going to have this maximum distance of 4. Now you could have been able to tell that from the equation, because we're not always going to give you the graph. In fact, I'm going to have you try one in just a minute. I'm not going to give you the graph. I'm just going to give you the equation. So let's say we didn't have that graph. Could we have figured out that the maximum value of R was 4? Well, yeah, because we know that sine, the biggest that sine could be, sine of whatever. It doesn't matter if that's 100 theta, or if that's 2 theta, or just theta, or x, whatever it is. Maximum of sine of anything is 1. All right. Well, if the maximum this can be is 1, 4 times 1, the biggest this can be is 4. All right. So we've got that the maximum equals 4. The kind of idea is thinking, if you thought back to y equals 4 sine 7x, that the amplitude was 4. If you remember looking at that amplitude of those trig graphs, so that there was a highest that it could go. It's that same idea. This number out front tells us the highest, the biggest it can be. All right, so then if we know that for the tip of the petal, that we're looking for R to equal 4, then that means we just need to plug in 4 for R and then solve for theta. So divide by the 4. Just remember, we can't touch this sign, or sorry, the 7 inside the sign. Things inside a function we can't touch. They're trapped inside that function. Don't change it at all. So we want to find, when does 1 equal sine of 7 theta? So remember, what we do there is we think, okay, just sine of what equals 1? Ignore the 7 theta for a second. Let's think about what has to be behind my thumb right there. Sine of what would be 1? Well, that's pi over 2, right? So my thumb has to equal pi over 2. Well, what was my thumb? My thumb was 7 theta, so it's 7 theta. That has to equal pi over 2. Remember, if you wanted, you could do a u substitution. You could say we want sine of u to equal 1. That means u equals pi over 2. All right, so then we have to divide by 7. So theta is pi over 2 divided by 7. Of course, that's 7 over 1. So that's pi over 2 times 1/7. Pi over 14 is the angle that we're looking for. All right, how about part B? How about a point on the graph that's at the origin? So we talked about that a couple times so far in this lesson about what happens when the graph's at the origin. So if we think about a polar point, so we know x and y, if we're at the origin, both x and y have to equal 0. What about polar? What was it for polar? We've got an r and a theta. Which one, or is it both, that has to be 0 to be at the origin? And it was r, right? If we're at the origin, that means r equals 0. Doesn't matter how you rotate, the angle can be anything. Theta could be 500 pi. Theta could be 500 pi, rotate a whole lot, doesn't matter. If r is 0, you don't have any distance from the origin, you're stuck right there. Okay, so for part B, we're going to plug in 0 for r. So 0 equals 4 sine 7 theta. Divide by the 4, don't touch that 7. 0 equals sine of 7 theta. So sine of what equals 0? When does sine equal 0? What angle has a sine of 0? When is the y-coordinate on the unit circle 0? That is the angle 0. So 7 theta equals 0. So theta equals 0. And again, if you need to, do that u substitution. Sine u equals 0 means that u equals 0. All right, so I'm going to go ahead and have you try this second one here. So I didn't give you the graph, but you shouldn't really need the graph. So for 2 cosine 5 theta, find me a theta that represents the tip of the petal and a theta that's the point on the graph at the origin. And again, we're just finding the first angle. There's lots more angles, right? We could have like added 2 pi, found different quadrant, thought about I guess they're quadrantal, but we could have, thought about lots of different angles that would have satisfied these. Just give us the smallest one. Tip of the petal and at the origin for r equals 2 cosine 5 theta. All right. So there's your answers there. This one for part A, it was 0. And for part B, it's pi over 10. Zoom in here. So for part A, we know that the maximum is 2. The amplitude would have been 2 if we thought about it as a function. So that's our maximum r value. So we wanted cosine to be 1. That's when theta is 0. Then for part B, at the origin means that r is 0. When is cosine 0? That's pi over 2 divided by 5. We get pi over 10.